All right, so you just did an activity where you took the last sublevel of a bunch of electron configurations and filled them in the periodic table. What pattern did you notice as you went down a group in that?
They all had, so if we're talking about group 1, they all had S's, and it was all S1.
Right, so as you go down group 1, it's all 1S1,
2S1, 3S1, 4S1, and so on.
Then what did you notice as you went across the periodic table?
So if we start with period 1, it went from 1S1 to 1S2. And then from period 2, it went 2S1, 2S2. And then it went to 2P1, 2P2, 2P3, all the way to 2P6.
Okay, so as we go across this, in groups 1 and 2, we have S's, all S1s down the first group, all S2s down the second group. We come over here, we have what's called our P block, if you think back to that thing we colored first thing this module. And so you have P1s all the way down, P2s all the way down, P3s all the way down. What about this middle section? What were we filling in the middle section?
Those were the D's.
The D's. And which D did we start with here?
I remember seeing that it didn't start with a 4 like I thought it would. It started with a 3.
Because remember, 3's go back to D, so 3D1 and D2.
All the way to 3D10, right?
All right, and then this bottom section. We didn't really get into that bottom section. What you need to know is this bottom section, those are going to be your F's.
Oh, that's right. Mr. Thompson talked about that.
So you have 4F1 all the way to 4F14. Yep, because we have up to 14. We don't deal in that section terribly often. You're not going to have many problems that deal down there. We'll have you do a couple practice maybe. But down there, it's a bunch of radioactive stuff you use to make things that we don't deal with. That will actually help us write our electron configurations, because if we know that we're in group 7, then what do we know our electron configuration has to end in?
P5.
P5 for whatever row we're in, and then you just fill in everything up to that point. So you don't have to actually do all your arrows out, you can just write it out. There's actually a way to make it even shorter. So let's look at chlorine. So chlorine has how many electrons?
Chlorine has 17 electrons.
Has 17 electrons. And what did we just say chlorine was going to have to end in?
P5.
P5.
He's in the P block.
And which row is he in?
3.
So we know we're going to have to end in 3P5. What comes right before 3P5?
3S.
3S2.
2.
And then before that is?
2P.
2P6. And before that's going to be?
2S2.
2S2.
1S2.
1S2. Okay? So that we know is going to be our electron configuration. So we know that because chlorine's a halogen, it's in group 17, it's got to end in P5, we just fill in everything before that. But we can make it even easier by using our noble gases. What did we say was special about our noble gases?
They have a full outermost shell, and they're all in group 8, and they're inert.
Right. So because they're full in their outermost shell, everything that could be filled to that point is filled. So we can actually use that as shorthand for our lower electrons. So if we look at neon, which is a noble gas right before chlorine, how many electrons does it have?
10.
10. And it's got to end in what?
A P. P6.
P6. So we're going to end in 2P6. It's going to start out the same way that chlorine did. So neon is 1S2, 2S2, 2P6. Chlorine has all of the same part for the first part, but then goes 3S2, 3P5. So what we can do is we can put neon in brackets as a shorthand for all the electrons that match, and then just fill in 3S2, 3P5.
Cool.
Okay, so let's try another one. Potassium. So potassium's got just a couple more electrons than chlorine did. So what is the next noble gas right before we have potassium?
Argon, AR.
AR. How many electrons does argon have?
18.
18. How many electrons does potassium have?
19.
19. So since argon has 18 electrons, that argon is going to count for the first 18 electrons. So how many electrons does potassium have past argon?
Just one more.
Just one more. So we can start with argon for the first 18, and there's one electron left after that. What's that very last electron going to be in potassium?
Let's see. It's in period 4, so it's going to be 4, and it's in group 1, so it's S1.
S1. So this is our first 18 electrons, plus the one past that gives us the 19 electrons that potassium has. So this is our noble gas notation for potassium. So yeah, it's really easy because you just take all of your electrons up to that point, shortcut it with the noble gas, and then put whatever's left over. Let's look at xenon. Xenon's got a whole bunch of electrons. How many does it have?
54.
54.
So I can just put that in brackets, right? Because it's a noble gas.
Well, except, does that really tell you anything about the electron configuration?
Well, it seemed like when we were picking it out earlier that you were picking out the noble gas that was in the period before it. So if Xe's in period 5, I need to pick out the noble gas in period 4.
So yeah, a lot of people would want to go, hey, let's just do xenon in brackets. Do not do that. You can't do that. You've got to use the one before. So we said krypton was the one before.
Okay, and that's got 36 electrons.
So this has 36 electrons. How many electrons are then left over?
It's 18.
18. So we need 18 more electrons. So if we start at krypton and come down, rubidium and strontium have which electrons?
So we need to do 5s2.
5s2.
4d10.
Because we're going to
go all the way across the D block. 5p6.
5p6. And see, we've got 2 plus 10 plus 6. This gives us our 18 extra electrons. So this is our noble gas notation for xenon. All right, so these were a couple examples. Now you've got a couple in your packet. Try and work them out first, and then come back and see if you ended up with the same thing we did. So before you get into your guided practice, a very important note. Each noble gas has a specific number of electrons that will help you pick which one you need. So we've got helium, which has how many electrons?
2.
And our next noble gas is neon, which has
10.
Okay. And then our next one is argon, which has
18.
And then we have krypton, which has
36.
And then we have xenon,
which is 54, we just talked about.
And then we have radon, which is
86.
86. So, if you're trying to figure out which noble gas you're using, you can look at the next row up on the periodic table, or you can just say, okay, it's got, say, more than 18 electrons but less than 36, so I know I've got to use argon.
Okay, so let me get this right. The only way that we can use this is if I use helium, I have to have more than 2 electrons. If I use neon as my shortcut, I have to have more than 10, not the same.